Okay, now what we're going to do is we're going to implement the backtracking solver for our Sodoku board. We're going to add that into our solver class, and we're going to create a class called solve. Come on down here. This is the main class that's going to be used, and what it's going to return is it's going to return a complete board. So solve will take a partially complete board, we'll call it partial, and it will return a solved board as a result. And the way we're going to do that is we're going to do that by doing backtracking solving. So the first thing, because this is going to be a recursive call, we need to go ahead and create a couple end cases. So the first thing we need to recognize is that if we're given a board that is not a good board, then we're just going to return false. And our false condition will be null. So that'll mean there isn't a solution to the partial board you've given us. So we'll say if not valid, this partial board, so we've already have the code to check whether something is valid, that checks all the rows, columns, and squares, then we're going to return null. If complete and valid, meaning that we have a good board, then we're going to return the board that is both complete and partial. So those are two possible ending conditions. Now, if it is valid so far, but it's not complete and valid, then what we need to do is we need to consider adding in additional numbers into the spots that don't have numbers and checking to see whether we can recursively solve that. So in order to do that, what we'll do is we'll make a copy of our duplicate board. Spell it right. Board, let's call it B, and that'll be a new board that's made from our partial board. So remember, we have our constructor that'll make a copy for us. And what we're going to do is we're going to go through each one of our rows and columns. And we're going to ask if our given board is empty in that spot. So we'll say integer I equals board.get column, comma, row. And we'll say if I equals null, meaning there's nothing there. Then what we're going to do is we're going to go through each one of our numbers that are available to us and try filling it in. So we'll make a copy of our checker set that's at the top. We'll say set integers try us equals new hash set integer, and we'll base that on our checker at the top, so that has a set of all the numbers in it. And we'll go through one at a time, and we'll say for new try in try us, so fast enumeration, number. Not try is a reserved word. All right, and that'll be an integer, and what we'll do is we'll say that board.set column, comma, row equal to the number that we're trying. So we're taking the copy of the partial board that we've got, and we're trying out to see whether putting a number in there is going to work or not. And then we'll say that our partial board, our solution, is going to equal a recursive call, not on the partial board, but on the one we just built. So we will try adding that additional number, and if it comes back, we'll say, well, if solution is not equal to null, meaning we got some kind of board back, then we're going to return that solution. But if it is equal to null, then it means that we weren't able to find a solution after substituting in that number at that position. And so we'll try the next number at that position. But if we try all of our numbers, and we get to a point where we've tried all of our numbers in a given position, and we weren't able to find a solution, then there is no solution available to us, because we tried all of our numbers at a particular square, and there were no solutions with that constraint. So we're going to return null in that case. And then, so if we get down here, that means that we've gone through all of our all of our rows and columns. We have made sure that there were no nulls, and let's see. And if we're able to return 2, so I guess in this case we'll return null as well because we weren't able to find a solution. Okay, and that's our backtracking solver solution. I think that's everything that we need. We'll know in a second or not. So without doing a full test, we'll give it a shot and see if that works. Actually, let's go ahead and do a test. I'm going to pause for a sec. Okay, so we've completed this solve method. We want to know whether or not it is working or not. So we need to write a test for it. So what I did is I went back to our solver test, and I wrote a test for a method that we implemented in our previous video. That method was for the complete and valid method. So how did I do that? I made a test called test complete and valid. I created a new solver, a new board, and I went through and I set each one of the elements on the first row to a solution. This is the solution from the Wikipedia. If you go to the Wikipedia page for Sodoku, there's a solution in the upper right. So I used that solution. And so I set the first row, and after setting the first row, we should see that that board is valid, but that it's not complete and valid. And so if we get through here, we've passed our tests. Then I set the second row. I verify that it's still valid. Oops, it's still valid, but it's not complete and valid. Then I set the third row. Verify that's valid, but not complete and valid. The fourth row, the fifth row, the sixth row, the seventh row, the eighth row, and finally the ninth row. Now when I'm done setting the ninth row, we see that it is valid, but we also see that now it is complete and valid, not complete and valid. So this is a valid solution. And when I run this particular test as a coverage test, we can see that it exercises this complete and valid function, and we get the right answer, that it passes. But what we wanted to do was we wanted to execute the solve method. So what I'm going to do is I'm going to take this valid and complete method here. This is in my tester class. I'm going to duplicate it, and I'm going to call it the solve method, test solve. All right, I'm going to create a solver, and I'm going to create a board, and I'm going to go ahead and set each one of those positions all the way down. But the last thing I'm going to do is I'm not going to set the very last position, the eighth position. We know that should be 9. So that should be blank. And so then as a result, it should be valid, and it should not be complete and valid because we have that last position that has not been filled out yet. So let me run that and make sure that it's passing so far. We didn't actually test the solve yet. I just want to make sure there's no errors up to this point. Okay, so far so good. Now what I want to do is I want to solve it, and since there's only one position left, I want to say s.solve, and we'll give it b as our partial board, and we want to return the solution, and we want to assert true that solution.get 8,8, we want to make sure that's equal to 9, which would be the solution for this board that we already have an answer to. And if we do that, then we know at least we have a little bit of confidence that our solution works. We don't know if it works completely. All right, so our solution that did work, we filled in our last spot, that's 9, so I feel pretty confident about that. All right, so what we've done then is we've implemented our backtracking solver for our Sodoku board. The last thing we need to do is we need to clean up our user interface so that we can connect the user interface with the actual solver.